Hey everybody, Mr. Rubo here. Today we are talking about exponential growth. An exponential growth function has this form y equals a times b to the x, where a can't be 0 because that would make the whole thing 0, and the base b is greater than 1. Okay. So let's look at our first example here of just one. Let's graph it real quick. So we have y equals negative 2 to the x. So I'm going to choose x values, and pretty much negative 2 to 2 in terms of the integers are usually pretty good values. So if you remember, anything to the negative power does the reciprocal, and then we just apply the power. So I get 1/2 squared, which is 1/4. Negative 1 to the power is going to be 1/2. 0, anything to the 0 power is 1. The first power just leaves it alone, so it's 2. 2 squared is 4. Okay, so now let me graph these points. So 1 right there, about half, 0, 1, 1, 2, oh, come on, and then 2, 4. So this graph will look like that. So you can hopefully clearly see that the domain is all real numbers. And then for the range, even though I was substituting in negative numbers, I was still getting a positive y value. So if we followed that pattern, there's no way of me getting a negative number when I'm raising something to a power, whether it's an even power or an odd power. It's still going to become positive as long as obviously that number is positive. Alright, so let's just go in general now. For the parent function for exponential growth is going to have that same general shape. Oh, computer's still going slow. So the graph rises from left to right. It is growing as you go left to right. And it's always going to pass through two specific points that are really important. The parent functions, at least. So 0, 1. That's always going to be our y-intercept, unless of course there is some sort of transformation done, but this is for the parent function. And then 1, b. So if I substitute 1 in, I'm always going to get whatever the base is. So those are kind of your two key points. Then the x-axis here is what we call an asymptote. Oh, and I'm going to probably spell it wrong, but that's okay. Maybe not. Which it's a line that a graph gets closer, which is a line that a graph approaches. I'm going to spell approaches wrong too. That's okay. Approaches, there's an E there, more and more closely. So it's going to get closer and closer to it, but actually never touch it. Okay. That's what's happening here at the x-axis. And usually what we like to do to identify those is, that's not green, is to put a dotted line wherever that asymptote is, because that's kind of telling us, oh, I'm going to be approaching it and getting closer, but I'm not ever going to touch it. Alright, so just to kind of throw in some transformations now, we can have this form where it's that a times b, now it's x minus h, and then a plus k. The way we're going to do this is we're going to start by graphing just the a times b to the x, and then the h value is the horizontal translation, and then the k is the vertical. So whatever h is, we're going to move left or right. Whatever k is, that'll tell us how much up or down. So, once again, you can use a table of values. It's kind of up to you. You can notice here I only have 2 spots because I kind of said the 2 main points you care about are 0 and 1. If you need more, feel free to plot more. Because there's no vertical shift, my horizontal asymptote is still at is on the x-axis. Okay, so that will only change if there's some sort of vertical shift. So if I substitute in 0, I get 1. 1 times 1/2 is 1/2. Substituting 1, so 4 to the first is 4, times 1/2 is 2. So at 0 I get 1/2, at 1 I get 2. So this graph will have that general shape going through those 2 points. So you'll notice, hey, my domain is all real numbers, my range is still y is greater than 0. Okay? So I want you guys to try B. It throws a negative in there, but it's still the same idea, right? Do 0 and 1, substitute 0 in, multiply by -1. Substitute 1 in, and then multiply it by -1. Alright, so now let's go into ones that have these transformations, these shifts. So if you want to kind of do it the way I said, you would start by graphing 4 times 2 to the x. Okay, so I'm going to do that first. So what's in red is 4 times 2 to the x. So that'd be 4, and then when I substitute 1 in, I get 8. So 0, 4, 1, 8. Now, this is actually not my graph, because I need to shift it. So it says x minus 1, well that would mean to the right 1, because it's the opposite of what we normally think, so right 1. And then minus 3 is what we would normally think, so it's down 3. Oh. Actually, let me change colors here. Oh, I love this computer, it's so slow. Alright, so just want to make sure. So right 1, down 3. Okay, so what I'm going to do is I'm going to take the points that I plotted, move them right 1, down 3, put my new coordinate point there if it wants to go in. Let's see, there we go. Do the same thing with this one, right 1, down 3, 1, 2, 3. Now I also move the horizontal asymptote there. Moving it right or left doesn't do anything, but down 3 sure does, so I'll have a horizontal down here at -3, and then I can connect my graph in the same fashion, trying to get through the points, but my computer's going super slow. So, alright, so you can see I translated it, right 1, down 3, it's the graph in blue. Hey, once again, all real numbers for my domain. The range now, though, it's still greater than something, but it's no longer greater than 0. It's greater than -3. Okay? I want you guys to try letter B. Same idea. It is +1, so you're actually going to shift it to the left 1 and then up 2 when you actually finish this graph. So left 1, up 2. And that will change, won't change your domain, but it'll change your range and then obviously how your graph looks. So here's some more examples if you'd like to try. Take your time, pause the video, but I won't go through these. These will be up on Canvas if you want to see the completed ones, or you could just put them in a calculator just to see how you do, whichever is quicker for you. So like I said, pause at each one of these, try it out, see if you can get it, check it using a calculator, make sure you get the same graph. And yeah, thanks for watching, and have a good day.